So this takes us to the growing market into electric vehicles and the type of batteries used there. This is EV.com, and this is just showing you a diagram of how the batteries can be placed in cars. Now, one component is basically that currently lithium-ion batteries are still the most common in EVs. They've earned their crown through a combination of good characteristics, high energy density. There are some times they are switching to NIMH, but mostly the market has stuck with lithium ions. They got a long life cycle. They can withstand thousands of charge and discharge cycles, which sometimes outlast the vehicle itself. So that's going to be crucial, and that's what they've evolved in. So the lithium, this is sort of what we're talking about in critical minerals now to make all of these batteries. So again, Tesla, Nissan, Chevrolet, anyone making these have invested heavily in the lithium-ion technology. And Tesla in particular has pushed the boundaries of lithium-ion batteries, constantly getting more energy density and performance out of the vehicles. NIMHs are in the market, but I think they're still outperformed a little bit by the lithium ions. They have their own benefits too. They can withstand numerous charge-discharge cycles, which is more important in hybrids, where the battery is constantly cycling as the vehicle switches between electric and gas power. Now the hybrids, I'm not sure what the market is changing right now for full electric versus the hybrids, but hybrids have been around for at least 10 years. Lead acid, but again, lead acid is it's not really appropriate. It's good for starting your car, but it's not going to last as long if it's driving it. In EVs, you will find lead acid batteries doing things like powering the 12-volt electrical system, but not powering the motor. Include power steering, brake boosters, and various safety features. A lot of cars now are going to steer by wire, which means the steering wheel is no longer mechanically connected to the front wheels. It's a sensor, and electrical components will be turning the steering wheels down below, which makes me personally feel a little nervous about that. But anyway, so that would be a 12-volt system still run by a lead-acid battery. Now there are references to solid-state batteries. This is not really a battery as much as it is a giant capacitor. And the beauty of these would be it's a capacitor. You can pull up to a filling station, plug in the electrical connector, and charge your capacitor. There's no chemical reaction, so the charging time would be about the same as filling your gas tank, and then off you go again. Now these are still maturing. Some companies are really investing in research. There was a company in Texas around 10 years ago or more that was making great strides, and then suddenly they went off the radar. No more news. I'm guessing somebody bought them up and is pushing that technology farther ahead. So solid state, the nice thing about it is they can't get into a thermal runaway that lithium ions can. As they get discharged, they produce a lot of heat, and that can cause a meltdown and a fire. That's one of the risks to a lithium-ion battery, almost like an explosion. That's one of the risks of chemically created batteries. So again, as EVs evolve, you're going to see more and more technology in that. They're talking about silicone anodes, which increase energy storage capacity. Efforts to reduce the carbon footprint and of all the costs and materials to build batteries are huge. Solid-state technologies would really make a big difference here. capacitors should have a long, almost unlimited lifespan if they are properly cared for. They will eventually wear, I'm sure, shorting, because even as you're charging and discharging, there are always stresses inside a battery. The same as a transformer, there's always magnetic field stresses on the conductors, and even though they're anchored, there are tiny amounts of movement. So these plates, if they were capacitors, would be flexing a little bit too. So another technology to be aware of and keep an eye on. There are many good websites you can search on. Here's one on power tools. It's kind of a summary on all our cordless power tools. It says this disclosure, this article was created using AI. So they're going out and getting all kinds of information too. A summary of battery types, NiCads, 7.2 to 18 volt. Now, that's about 1.2 volts per cell. So that's a combination of batteries. That's the older one that's being phased out, durable and long-acting, good performance in extreme temperatures, but memory effects limits charging. They're heavier and less efficient than newer options. NIMH, again, power tools, better capacity than NiCads, less harmful for disposal, a little more temperature sensitive, and a little shorter lifespan than lithiums. Lithiums are now being developed. They're pushing the power tool voltages. Because each cell is over 3 volts, they can collect a lot and get a high voltage power pack for your tools. There are power packs that are 40, 60 volts. Now, this means just more and more cells strapped together, but it does give you the voltage you need. And power tools, of course, the higher the voltage, the less current that's flowing, and the longer life you're going to get out of that battery for each charge. Lithium packs are lightweight and compact, long lifespan, more energy efficient, but their upfront cost is high, and they can overheat if they're not properly monitored. So how do you make a battery last longer? More frequent use may lead to battery depletion. It just depends. They've got a lifespan on charging, discharging cycles. Charging practices are really crucial for a lot of these batteries. Never overcharge or never completely let them go dead. And temperature. Keeping them in extreme temperatures can reduce their performance. Cordless power tools really shouldn't be stored in your garage at minus 20 in the winter. They should be kept a little better. They will perform better and probably last longer. Again, batteries can be stored in a cool, dry place. Don't leave them in the power tool when not in use. Charge them before they go completely dead, no less than 20% remaining charge, and follow the manufacturer's recommended guidelines. So different tools require different batteries for different types of loads. Some power tools that take a high torque, like cordless chainsaws and things like that, grinders, they might need a different type of battery or just definitely a larger battery. So again, lots of information, pros on the web. Pros and cons are all listed. And now those were all rechargeable batteries. So one thing we should also take a look at would be, and on this document I put a link here. It's Electrical for You, alkaline batteries. These are your standard small batteries. They are not rechargeable. And you just use them until they're depleted, and then you dispose of them. Now, alkaline, as the name, is a base. It's not an acid. And they have a can, a little outer jacket, a little can, with carbon manganese dioxide, separator, and then powdered zinc potassium hydroxide, which is an electrolyte, and they've got a brass pin. Now this chemically reacts to produce a voltage. And these things, they just run until they're depleted, and then you get rid of them. They will leak sometimes when they get old. I'm sure we've all seen batteries that have been left in a device, and you get this crusty sort of powder on the outside when they've leaked and it dries out. Incidentally, if you want to clean that out, spray a little vinegar, which is an acid in there, and it will dissolve all of that stuff. And even if it's on the contacts of the device, once you've pulled the leaky battery out, if you spritz a little bit of vinegar there, the contacts will just come out shining brand new with a wipe of a Kleenex. So, working principle, use zinc and manganese dioxide as the electrodes, potassium hydroxide as the electrolyte. It's a reaction between those two, and it's just basically a drum, and they offer high energy density, low internal resistance, long shelf life, low leakage, and good performance. But they are disposable. So again, that's the cost. We can't recharge them, and there's lots of good information about it too, a little more in the ways of the diagrams. It's been around for quite a while, so all right, that's a good introduction. If you're interested in more, the first link that I put in this document, let me get in here again, as it loads. This link is a good watch. Really gives you a good overview. Okay, that's about it for batteries. And I'll be talking to you soon.